Okay, guys. So yeah, let's get started without any further apologies. I was away from the keyboard. So in today's class, we're gonna go with the upcoming few topics left out, which is how do you assign a private IP to your system, both manually and automatically from a DHCP server. Now, if you were the network admin for an organization, it was your responsibility to go to every singular system and see to it that it got an IP address. Okay. So there's a way of assigning an IP to every system manually. You can go to your control panel, and in your control panel, you can search for network and internet. You can go to network and sharing center. In that, you go to change adapter settings. Then you right click on the required adapter. And then you go to the properties, the IPv4 properties, and then you assign the IP address. Okay, so this is the actual step-by-step procedure to assign an IP manually to every system. Okay, one by one. So if I show you this practically as well, I can just search for control panel. In the control panel, I go to network and internet, network and sharing center, change adapter settings, and then I right click on the adapter, whichever adapter I want to change the IP for. Go to the properties. In the properties, I select IPv4 properties, and here I can assign the IP. So right now I'm getting it automatically from a DHCP server. But if I have to assign a manual IP, I select the second option here, and then I specify the IP. Okay. Right now, currently my system is getting the IP of 192.168.0.3. But if I had to change this, I can specify the IP here. Let's say 192.168.0.50. Okay. Now, since this is class C, subnet mask for this is 255.255.255.0. We know class C has three network portions and one host portion. Therefore, the subnet mask is 255.255.255.0. Okay. And the default gateway is my router's IP. So usually in my network, the first IP is the router. So I specify 0.1 here as the router's IP. And along with this, it needs two other details as well, DNS server IPs. Just in case if you don't know what to enter here, you can go to your browser. And in your browser, you can do a quick search, Google DNS server IP. Okay. And that shall provide you two IP addresses. One is 8.8.8.8, and the other one is 8.8.4.4. And you can use either of them. So you can specify 8.8.8.8 or 8.8.4.4. Okay. And now when I click on OK, that specific IP will be assigned to my system. Okay. And if that IP is being has already been assigned to any other device, then it'll throw you an error saying this IP is already assigned. You have an IP conflict error, and you have to change the number here from 50 to something else. Okay. So, but again, if you were the network admin and if you had no DHCP server, this is the procedure. Again, what you have to fill out information for to assign an IP to each system. So like this, I have to go to every device and I have to open up their control panel. And over here, I have to assign the IP. This is the manual method. Now, for small networks like 10, 15 devices or so, this is completely fine. It's not that big of a deal. But if your network is too large, let's say like 500 devices or 600 devices or so, in such a scenario, you going to each system and assigning an IP is quite a hectic task. It is not quite possible every single day. Okay. To troubleshoot as if any one device doesn't get an IP, you going to that system and checking what IP it has lost is again quite a headache. Okay. That's why we have something called a DHCP server, Dynamic Host Configuration Protocol server. Okay. So this protocol, DHCP, basically is to dynamically or automatically assign an IP to each system in the network. Okay. So DHCP, basically from the name itself, you can figure out it's dynamically or automatically configuring an IP to every host in the network. And that happens with something called the DORA process. Okay. So in our home network also, we have a DHCP server. You might not know, but your Wi-Fi router itself acts as a DHCP server in your home network. Okay. So that Wi-Fi router or your DHCP server has a pool of IPs, a pool of free IPs. And from that pool to each system, it assigns a unique IP. And that process of assigning the IP is called the DORA process. So we're going to talk about the DORA process now. What is this DORA and how does it assign an IP automatically to every system in the network? Okay. Is that any questions or doubts up to this point? Anyone? Raja, Muktesh, Gurudatta,
No, sir.
Rani. Shiva
No, sir.
Sai. Okay. Josephine, I hope you can hear me as well. Any questions? Right. Okay. Moving on, let's talk about what this DORA process is and how we are getting an IP assigned. Okay. So when you talk about the DORA process, guys, this basically is when one of your devices is connected on that DHCP protocol. So when I go to my control panel and when I select this option here, this first option, which is obtain an IP address automatically. So when this option is selected on my system, what my system starts doing is it starts sending something called a broadcast packet. Okay, let me explain this with a simple diagram. Yeah, so here. So let's assume this here is my system, my newly connected device. Okay, and this here is a DHCP server. Okay, so this is my DHCP server, which has a pool of 3 IPs. Okay, so your server gets the first IP in the network, and the remaining IPs are mentioned over here as a pool. So second IP, then the third IP, then the fourth IP. As such, it has all the other IPs as well, up to the last IP. Okay, up to 54. Okay, you never use the last IP, guys, which is 192.168.0.255. This is called the broadcast IP. Okay. So what I mean by broadcast IP is if a packet is sent to this IP, it is sent to every other device in the network. Okay. And that is what is used here for broadcasting. Okay. Whenever you have a new device connected in the network, and let's say if there are other devices as well here. Okay. Whenever you connect a new device, this device starts broadcasting a signal to every other device in the network. So it sends a packet to this device, it sends a packet to this device, it sends a packet to this device. Okay. And this packet is called the discover packet, basically. Okay. So basically, it's trying to figure out who the DHCP server is. It's asking every system, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? When it reaches the wrong devices, they just block the packet. They don't respond to it at all. Okay. So they just ignore it. But when this packet reaches the correct DHCP server, that server responds back saying, hey, I'm the DHCP server in this network, and I can offer you an IP address. You were looking for me, and I have a pool of IPs from which I can offer you a certain IP. Okay. So whatever available IP is there, it offers that IP. Something like, let's say, 192.168.0.2. Okay. Once that offer is made, then your client says, hey, thanks for offering me that IP. I request you that you allocate that IP to my system and don't assign it to anyone else. Okay. So now a request is generated to confirm or to, let's say, reserve that IP. Okay. And for that, your DHCP server finally sends a confirmation back saying, hey, I've got your request. I understand that you need this IP. And I acknowledge that. So now an acknowledgement is sent. And with this acknowledgement, that IP from the pool is removed now. So now this IP over here, 0.2 is removed and it is assigned to the system here. Okay. Because again, if it is still existing in the pool, it will get assigned to someone else. Okay. So it is removed from the pool and given to the system here. And this whole process is called the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. Okay. So as mentioned, whenever you have a DHCP server, first your client sends a discover packet, server responds back with an offer, then your client sends a request, server acknowledges that request and assigns the IP. Okay. So again, all of this happens very spontaneously, guys. I'm pretty sure you might have observed this at least once in your life. Okay. Whenever you connect a new phone to a Wi-Fi router, so when you enter the Wi-Fi password and click on connect, for a very short duration, you see this message obtaining IP address. Okay. Just in case if you want to experiment, forget again, try to click on forget network in your phone and try connecting to your Wi-Fi router again. Okay, enter the password and click on connect. And for a very short duration before it shows connected, it shows obtaining IP address. So that is a procedure where after the correct password is entered and after you have authenticated on the Wi-Fi network, your system, your phone starts communicating with the router and performs the DORA process. So while that process is happening, you see that message obtaining IP address. Okay. Any questions regarding the DHCP protocol? Anyone? Raja, Bipin, Sahu. Guru Datta, Praneet, Shivasai, Muktesh. Does anyone want me to explain this again?
Sir.
I joined just now, actually.
Oh, okay, start. No worries. Again, just in case, guys, if this is your first session or if you have joined late, do not worry. All of these sessions are being recorded and you can find them on the official website of the institute. And as mentioned, uh, if you have any further queries after going through the recordings as well, you can directly ask me in the upcoming sessions as well. I can repeat again the topic which you are confused with.
Okay.
So yeah, others, whoever has joined earlier, any questions or doubts, whoever has been there for the entire topic.
So we have any
Guru
doubts?
Datta. Raja. Yeah, Raja, you're saying something.
No, sir. No doubts.
Okay. Moving on. We know what a DHCP server is. Let's talk about a DNS server. So when we were assigning a manual IP, we were asked to enter something called DNS server IP. Now, what is a DNS server and why do we need it? To explain in a very simple, with a very simple example, your DNS server is like your internet's phone book or the contacts application. So your phone has a contacts app. What does that contacts app do? It links every contact number with a contact name. We humans are terrible at remembering long series of numbers, okay, especially 10-digit numbers. Okay, that's quite tough. Okay, remembering 5 or 6 contact numbers is fine. Remembering hundreds of numbers is again not practically possible by all human beings. Okay, some are special cases, some are very miraculously intelligent that they can remember every contact number, but not by again. But I am sure 99% of the people can't. Okay, so to make it easier for us, we have this contacts app where whenever there's a new person, if you want to save my number as well, you get my 10-digit number and you assign it some name, okay? Shoaib or cybersecurity trainer or DURGASOFT trainer, whatever it is. Okay. Now, whenever you try to contact me, guys, what is relevant for your 10-digit SIM card is my 10-digit SIM card. It is not relevant what you save the name as. The name is only for you to recognize me. But to initiate the connection from your device to my device, the two important things are your phone number and my phone number, your 10-digit SIM card number and my 10-digit SIM card number. On those numbers itself, the connection is made. Okay, the phone call is placed. Okay. Similarly, when you go to your browser, and in your browser, when you search for www.google.com, your browser does not understand this language. It doesn't know what google.com is. What it actually needs to connect to Google is the server IP. So this google.com website is hosted somewhere on the internet on a certain physical web server. And that server has a public IP. So your browser actually needs that IP address. Okay. And that is obtained from something called a DNS server. A DNS server has something called records in it. And that record links every domain name to its exact IP, correlating IP. Google.com stored on so and so IP. Bing.com stored on so and so IP. YouTube.com stored on so and so IP. Shrow.com stored on so and so IP. So it has a record for every domain that has been hosted on the internet. Okay. And from that domain, it gets the IP. And with that IP, it reaches the correct intended server. So a DNS server is like the internet's phone book, translating human readable domain names into IP addresses. Okay. So when you type a URL in your browser, that URL is sent to the ISP where ISP has its DNS servers. And that DNS server resolves or converts the domain name into its corresponding IP address. And from that, it allows your device to connect to the intended web server on that IP. Okay. To show you a practical example for this. So just give me 1 second, guys. I think my laptop's battery is down. Let me connect the charge. Okay. So I hope you can hear me now. As mentioned, whenever you connect to google.com on your browser, when you go to your browser and when you search for www.google.com, your browser doesn't understand this. What it needs is the exact public IP. So if I had to get the public IP, I can use a command called ping. Ping is is a tool available in your command prompt, which uses a protocol called ICMP to send some packets to the website you mentioned here. So if I give ping google.com, that sends some packets from my system to Google server. Okay, these packets are called ICMP packets. Okay, and you can see here, I'm getting a reply back from Google. But when I'm getting a reply, I'm getting an IP address here. So if I copy that IP, if I go to my browser, and if I paste that IP here, 142.250.182.4, and if I hit enter, carefully observe what happens. I get the website google.com. So this was the actual IP for Google. So again, the website google.com is being hosted on the web server with this public IP. So if there were no DNS servers, I had to remember this IP every single time I had to connect to Google. So this is like the contact number for Google. And that google.com is the name, the domain name. Okay. So a DNS server is like a contacts application linking the domain name, google.com, with its exact responding IP address, okay, corresponding IP. Okay. And since the help of the DNS server, we don't have to remember these IP addresses. We just need to remember the domain name. Okay. So the linking is done in the background with the help of a DNS server. Okay. Is that clear, everyone? Mahid, Joseph, Raja, Muktesh, Gurudatta, Praneeth, Shivasai. Any questions?
No, sir.
Others, any questions? Raja, Gurudatta, Praneeth,
No, sir.
Shivasai.
Yes, sir.
Perfect. Moving on now. Let's talk about one more important concept called special IPs. So in your entire range of IPv4 addresses, guys, from 0000 to the last IP, 255, 255, 255, 255, you have two sets of special IPs. One is called the loopback IP, and the other one is called the APIPA IP. Okay. Loopback IPs, again, both of these IPs, guys, please note, are neither public IPs nor private IPs, which means they cannot be used for networking purposes for connecting one device to the other. They're only used for troubleshooting. Okay. To figure out if there's something wrong with your system, with your network, you can use these loopback IPs. Okay. I mean, sorry, the special IPs. Okay. First category is the loopback IP, ranging from the number 127.0.0.0 to 127.255.255.255. So this entire range of these IPs is called loopback. Okay. And they serve only one single purpose, to check if your system's NIC card is working properly or not. So they're the address allocated to your NIC card. What do I mean by NIC card now? So if you go to your browser, in your browser, if you search for NIC, this is what your NIC card looks like. It stands for Network Interface Controller Card. Okay. So if your system has an Ethernet port, okay, right beside that Ethernet port, you have this NIC chip. Okay. And this NIC chip is containing all the physical components of your network interfaces. So your Ethernet port physical component, your Wi-Fi chip, Wi-Fi chipset, the Bluetooth chipset, all the networking adapters, physical components are present on this one single NIC card. Okay. And if this malfunctions, none of your system's interfaces will work. Okay. None of your devices, again, none of the interfaces, Wi-Fi interface, Ethernet interface, Bluetooth interface, none of your interfaces will be able to retrieve an IP address. Okay. And therefore, you will not be able to communicate with any other system. Okay. And just to verify if your NIC card is working properly or if it's functional or not, you can ping any IP from this range. So basically, you're pinging your own system, hence the name loopback. You're trying to form a loop there by connecting back to your own device. Okay. So if I go back to my command prompt, and if I run a command here, ping 127.0.0.1, okay, or I can give any IP, ping 127.255.254, 120, any random number. First octet should be 127. That's the only condition. And you still get a response. You should get a response. If you're not getting a response, it means that an IC card is not working. Okay. If you're getting a response, it means everything is perfectly fine. Okay. That's what loopback stands for. So if you were to ask me, this was a huge wastage of IP addresses, frankly. So this problem has been omitted in the IPv6 addresses, where there's only one address for loopback rather than an entire range. Okay. And then you have the next IP called APIPA. automatic private IP assigned addresses, and these range from the number 169.254.00 to 169.254.55255. And these are special IPs which are assigned to your system by the OS, operating system itself. So in a case where your system is unable to get an IP both manually and automatically, in such a scenario, the operating system itself assigns an address. Okay. So the Windows OS or the Linux OS or the Android OS, okay, this operating system assigns an IP to your NIC. Okay. And this ranges from the number 169.254.00 to 169.254.255.255. So when you get this address, it basically indicates that your device is unable to retrieve an IP from other sources. And you have to check out what the issue is, whether with your DHCP server or whether why you're not assigning a manual IP. Okay. So these are the two special IPs available. One second. Okay, can you hear me? Am I audible, guys? Any questions or doubts regarding these special IPs? Mahid, Josephi, Muktesh, Raja, Gurudatta,
No, sir.
Praneeth, Shilasai. Does anyone want me to explain anything again? Any queries? I see a lot of silent or muted mics. Muktesh, any questions? Raja, any questions? Gurudatta, any questions? Praneeth, Shivasai, please do not hesitate to let me know, guys. Again, quite important concepts will be covered. Again, we'll be talking about these. These topics will keep coming across multiple times again in the upcoming sessions. Okay. So we'll be using these loopback IPs a lot. We'll be talking about these DHCP servers, DNS servers a lot. Oh yeah, Mahid, your hand is raised. Any questions? Special servers are a separate category. Special servers. What do you mean by special servers? These are special IPs again, Mahid. Nothing is related to servers. These are IP addresses. So these IP addresses are neither public IPs nor a private IP. So they are a separate category, which are used only for troubleshooting. Okay, yeah, special IPs, exactly. So they're only used for troubleshooting and they're not used for connectivity. Okay, they're not used for connecting or networking, only for troubleshooting purposes. Yeah, not for networking purposes. Correct. Right. Moving on to the last concept in networking, CIDR. Okay. So this is an alternative for subnet mask in your APIPA is only for workstations or domain systems. Again, works for all devices again, Tish. There is no restriction that you cannot get it in your local Windows 11 client operating system as well. You get it for all operating systems on all endpoints. Okay. Works on all operating systems, Windows client operating systems, Windows server operating systems, or Linux as well. Okay. Moving on, when you talk about CIDR, this is an alternative for subnet mask ICE, which is used in Linux operating systems. Okay. So basically, the CIDR is calculated with the number of network portion bits. Okay. What I mean by that is sometimes you see addresses like 192.168, 192.168.0.10 slash 24. Okay, so you see these numbers, you see a slash and then a number after that. So this is called the CIDR notation, guys. Okay, classless interdomain routing notation. That number is denoted by the number of network portion bits. So class A has one network portion where there are 8 bits in it. So the CIDR is /8. /20, /16 indicates class B. So class B has 2 network portions, 8 plus 8. So that is /16. And for class C, you have 3 network portions, 8 plus 8 plus 8. So 8 bits here in network portion, 8 bits here in second octet, 8 bits here in the third octet. And when you add all that up, you get /24. Okay. So whenever you see those numbers with a slash, it just indicates which subnet mask it belongs to. So if you something like 172.30.40.50/16, the /16 is to indicate that this is equal to the subnet mask of 255.255.0.0. Okay. If you see something like 10.0.0.10/8, it indicates the subnet mask for this is 255.0.0.0. Okay. And /24 indicates 255.255.255.0. Okay. So that's the CIDR representation or the alternative subnet mask. Okay. And this is the last concept for networking. This concludes all the networking prerequisites required for cybersecurity. In the next session, we talk about the practical lab setup installation. Okay. How do we install VMware? So VMware is a virtualization software which allows you to install other operating systems. So the next session, guys, we're going to learn how do you install VMware, and within VMware, how do you install these other operating systems? Kali operating system, Windows 7 operating system, Metasploitable. So this is our practical hands-on lab setup, guys, a simulation to understand how to perform practical attacks from one operating system to the other one. So we'll be learning how to install all of this in the upcoming sessions. So for the next session, guys, you will need your laptops, okay, so that I can show you how to perform this installation. I'll be sharing these softwares as well. And you can perform the installation in the next session. Okay. But please note, we won't have the session tomorrow. Tomorrow is August 15th. We all know that August 15th is our national holiday. Okay, so it's our Independence Day. We have no session tomorrow, guys. Okay. So tomorrow is a national holiday, no session tomorrow. Next session is going to be on 16th, which is Friday. Okay. So on Friday, we will have the setup for, again, the class for lab setup installation. Okay. Please note Joseph and Mahid as well. We have no session tomorrow. It's a national holiday here. We'll be connecting back on 16th of August. Okay. Any questions, any doubts up to this point? Mahid, I hope you can arrange your system by then for the practical sessions. Right. Any other questions? Raja, Muktesh, Guru Datta, Shiva.
Not from my side.
Sir, if 10.0.0.0.8/9 will be the subnet mask. Again, that's called subnetting, Muktesh. Sometimes you see something like 10.0.0.0, and you'll have something like /24. Okay. So this is a much more in-depth concept called subnetting, where /24 now makes this class A act like class C. Okay. Which means now your class A will not have the entire network to itself. Okay. So what it is going to have now is, oh, 1 second. So by default, when you have this as, let me increase the font. Yeah. So now by default, when you have 10.0.0.0/8, what this indicates is the entire network is from 10.0.0.0 to 10.255.255.255. This is the entire class A network. Okay. But when you have something like 10.0.0.0/24, now this starts acting like class C. So again, this entire network, big network, is divided in smaller networks. Okay. So the first subnetwork is from 10.0.0.0 to 10.0.0.0.255. Okay. The next one is from 10.0.1.0 to 10.0.1.255. Okay. Then the next subnet is 10.0.2.0 to 10.0.2.255. Okay. So this bigger class is being divided into smaller classes, okay, acting like class C here, where each of these is a separate subnetwork in the main big network. Okay. So subnetting is breaking one larger network. If I draw this out, so breaking one large network into smaller parts, okay, dividing it in smaller parts. So that is called as subnetting. Oh, sorry. I'm breaking it down in smaller, correct? Yeah. Breaking it down in smaller chunks of networks. Okay, that's called subnetting. Again, a very deeper concept, not required for our syllabus. Okay, but you can get a lot of data about it on subnetting from the internet. You can do some research on that. Okay, so but if you give the default values, they indicate the same network classes as your default subnet mask. Okay, /24 indicates class C, /16 indicates class B, and /8 indicates class A. Okay. If you have any other values other than that, it means the class has been subnetted. Okay, that's what it indicates. Okay. So yeah, that's that. Nothing further for the session today, guys. Any questions before we exit? So we'll be connecting back on Friday again for the last demo for you all, where we talk about practical hands-on lab setup installation. So that is going to act as a practical demo for you to understand what we'll be working on in the upcoming sessions practically. Okay. Yeah, Mahi. CIDR is mostly used in Linux operating systems. It's not used in Windows much because in Windows you have subnet mask. Yeah. Any other questions? Raja,
Sir,
your
is
mic.
there any problem with VirtualBox?
Yeah, you can use VirtualBox as well. The reason why I'm preferring VMware
No.
is because again, it's in this year VMware has gone completely free. So if you want to use it for single user, you don't have to make any payment. Until last year, VMware was paid application. From this year, they have released it for free for everyone to use, and it's a much better. It has a much better interface compared to VirtualBox. So that's why I prefer VMware. But alternatively, if you want to choose VirtualBox, you can go for VirtualBox as well. Okay, it's your choice. No issues with that. Okay. So when they're giving that good a software for free, why not utilize it is my question. Okay. So again, I'm going to share the link for the
Okay.
VMware application. If you want, you can use that. If not, you can stick with VirtualBox as well. Right?
No. I already installed a Palila message
Oh, okay,
VirtualBox.
okay.
That's
Again,
why.
if you already have the installation, don't delete anything, Raja. You can work on VirtualBox itself.
Okay.
Again, that's double the work. You
Okay.
uninstalling all this and then installing in VMware again. Again, too much headache. Okay. So don't, again, if you're working on VirtualBox, that's completely fine. You can use that also. Anything works. Okay. Right. So again, the
Okay.
procedure I'm going to show is for people who have not had any previous installations. So our topics will be discussed on Friday. As mentioned, Muktesh, we'll learn how to install the practical lab setup. How do you install Kali operating system and a software called virtualization? We request the training team that they send recording in the afternoon versus at night. Oh, sure, Mahid, I'll let them know that they send the recording at the earliest. Because right now it's over here at 8 p.m. or something. So they might be leaving work by now already. So, but I'll see to it. This recording needs some time to get converted. So once it's converted, I'll ask them to share the recording at the earliest. Okay. In a couple of minutes, maybe. So that you get it at the earliest and you can work on it. Okay. Sure. That's that. Nothing further for the session today, guys. We can exit here and we'll be connecting back on August 16th. Please note, tomorrow there's no class. It's a national holiday here. Okay. Bye-bye. Take care. See you on 16th again. Happy Independence Day, guys. Bye-bye.
Yes.